Hi, my name is Susan Wu. I'm in NSBU product marketing. And with me, I have Tuan Nguyen. He's in technical product management in NSBU. Today, we're here to talk about VMware Tanzu Service Mesh. We'll give a quick overview and then we'll dive right into the demos. That's what folks love for the code sessions. So just to give everyone a background, the application are being transformed. What used to be monolithic applications where development teams work off the same IDE, check in code at the same time, and do perform testing as in waterfall method, that's been changed largely with the advent of microservices. Now, teams that build the services, they can choose their programming language, they can choose their own programming language as well as the database backends, and they're making choices. What's important though is that this gives the teams velocity, feature velocity. They actually no longer have to wait for other teams. They can revise the software at the intervals that they want. But what's different and implement resiliency in their applications, they can adopt the new frameworks, as I mentioned. But what's different is that these services actually still need to connect and they need to be secure. The communications between services need to be secure and connected. And that actually brings out a different set of challenges, right? So these application teams are now working in silos, right? They're choosing their own frameworks and they might deploy their services on different clouds. And what's important is they still need to have the responsibility of securing. So they need to monitor the endpoints, secure the endpoints, and scale the endpoints. And probably the hardest is being able to implement the consistent policies across all of these services. And lastly, almost every organization is still undergoing, compliance and auditing. So that makes it very difficult when you move into the microservices paradigm. And so VMware engineers actually realized this and wanted to build something that's enterprise class. And so the enterprise class service mesh, provides all of these capabilities. So it provides the capability of running on multiple compute platforms, running on multiple cloud, and you can actually use more than one type of service mesh. There is a federation capability with multiple vendors and an open source project called Project Hamlet that would allow information to be passed between service meshes. And the service mesh provides a centralized visibility and a global control plane for you to implement the policies. And what's very unique about Tanzu Service Mesh is actually it has global policies for users and services and data, whereas other service meshes only focus on service and to service communications. And I mentioned the ability to address these auditing and the security compliance. And the most importantly is there's no code change that's required. So developers work the same way and they can implement Tanzu Service Mesh to connect and secure their application. So let me explain the whole portfolio. So on March 10th, there was an announcement of the whole build, run, manage portfolio around modern applications. So there are tools for building like Spring and frameworks. There are solutions for runtime. So how Tanzu Service Mesh fits into the managed part, and I'll have some discussions on how the two will work together. The service mesh, Tanzu Service Mesh, will work with Tanzu Mission Control. So as I mentioned before, the Tanzu Service Mesh is enterprise class. It's because we have the capability of not only service to service communication. So we have the full range of functionality for discovering the services, providing visibility of the services, and controlling the services and securing the services, including the MTLS encryption. All of these are applied to users, services, and data, not just services. So, unlike other solutions that only have this capability, we actually have the full range. Let me just kill them. I'm not sure it's showing up on screen. And not only can we support Kubernetes clusters, As I mentioned, you can implement service mesh and control your microservices across public clouds. And with integration with the load balancer, we can support even applications that comprise of virtual machines. And then with our extensibility platform, we can actually provide capabilities for SaaS applications and serverless applications. Let me explain a little bit the architecture of Tanzu Service Mesh. So Tanzu Service Mesh is built on top of the open source technology, but it adds a global controller. This controller provides all those capabilities that I mentioned, and it can control these clusters deployed on these different clouds, whether it's on premises, like maybe Kubernetes on premises, or whether it's a managed Kubernetes service on the public cloud. It actually controls the full service mesh installation, the global controller, the full service mesh installation, and the lifecycle management of all the clusters. And then it actually monitors the health and maintains the configurations. And you, as an operator, you can define the type of SLOs. And if the system is not behaving in the way that's been defined by the operator, the service mesh is smart enough to auto remediate and provide the resources so that it will work as the intended state. And then, as I mentioned, there is the third party extensibility framework so that you can add components into the solution. So this is the Tanzu service mesh, further explained how it works. So it works by adding in a sidecar container into the application, but with into the service, but with no need for code changes. And for the public cloud, you can actually federate with other service meshes. And then, as I mentioned, for VM and bare metal workloads, we achieve that by adding the integration with the Avi load balancer, which has recently joined VMware, I think last year. So with this, the service mesh actually provides the whole life cycle of this. And using all of these technologies, it is a fully comprehensive solution for all types of workloads, whether it's a VM based, a container based, or bare metal based. And then with the third party integration, you can add SaaS and serverless to this platform. So the global namespace is something that is unique to Tanzu Service Mesh. So the notion of namespace actually comes from Kubernetes as a isolation. The downside of the namespace is actually unique to one Kubernetes deployment. But with global namespace, this concept, the VMware engineers expanded on that concept. It is a logical concept that is not tied to any particular cluster and enables the applications to be stretched across multiple Kubernetes clusters. So you can see the application using the example of, say, a staging environment or a production environment. We can offer all of the full features that I mentioned, like discovery, identity, and policies and traffic routing. But it's defined for that application, but not limited to, say, one Kubernetes environment. So you can stretch that across, say, your on premise or into a public cloud. So that is a unique thing that we built into the system. So then you can define consistent routing policies, the application resilient policies, and security policies for that particular app, regardless of where the actual infrastructure lies or wherever it's been deployed. So that's the importance of something like this, because now you no longer have that restriction of the underlying infrastructure, and you still can stretch across all of the Kubernetes policies. What's very unique about this is this global namespace, we call it GNS. You could use that to be like a tenancy model. And you can define that applications for maybe a business unit or an application team. So you have the full flexibility because this is a logical concept. And then once you have that, you can allow your developers to work on the business logic without having to worry about the underlying infrastructure. Let me share a quote from one of our largest telecom customers. They said that the first time they saw this federated policy across the clusters and cloud actually working in their environment and done in such a logical and smart way, this is just a fantastic way to abstract this, across the different clouds. So there you have it. Let me turn it over to Tuan to give you the demo so you can see the global namespace in action. Let me stop sharing. Okay, Tuan, you can go ahead and share your screen.
Yep. Yeah, let me share my screen. Give me 1 second. Okay, so let's first start with the topology, what I have in the lab, and you can see how things been laid out. So we have a topology with multi-clouds where I have some application running on AWS, something running on Azure. I have 2 data centers called SDDC1 and SDDC2, where on pairing with the transit gateway between them and connect them together in the single big enterprises in the multi-cloud. So in this cluster, I'm gonna deploy some Kubernetes. So I have one running on-prem on SDDC1 and using NCP and provided by NSX. Another cluster running Kubernetes on AWS, where I have VMware Antria open source CNI. Another one running Azure with run a third-party CNI, could be anything. So, and then another one running second data centers. So I focus on one of the things running on AWS and showing how easy we can do everything from scratch in one single click, right? And now after that, I gotta walk you through how Tanzu can come in and do the onboardings on those Kubernetes in different environments. And the 2 things on the demo, the TMC, Tanzu Mission Control, to manage all the cluster and compute and storage. And Tanzu Service Mesh gonna do the networking plumbing for all the clouds together in the layer 7 like Susan just mentioned. Susan, you want any comment before
This
I
is
show
amazing. So you are now able to see the Kubernetes clusters on premise, on vSphere, and on AWS, and you can see an application stretching across the clusters. CNI actually stands for Container Networking Interface, and so from VMware, we have something that you know and love called Network Container Plugin NCP. There's also a in-cluster Kubernetes native networking project called Project Antrea. Feel free to check that out on GitHub. That is completely open source.
Right now, I have a lot of apps running, so I'm gonna deploy one more Kubernetes cluster from scratch. So I'll launch a new instance. So very quickly, in 5 minutes, we get everything up and running from scratch. So we have a company from VMware acquired called Bitnami. So Bitnami have some application, and one of those is the Kubernetes been offering. So they offering the So they offering the building Kubernetes and ready to go. We just go and grab the on AWS and one on to the interest of time. I go to a standalone. So my connection looks slow, but normally it should be very quick. But quick here is the sandbox concept. So we just go and grab the image and ready to go. And then
yeah, so right now Tuan is taking a image from the Bitnami catalog and is trying to deploy that image onto AWS.
Yes. Let's select one. Hey, Susan.
Yeah, so we
I
just
think
lost the screen from you. If you want to, you could try sharing again.
I'm sorry, I got disconnected somehow. Okay, let's go back. So.
Yeah. Okay, sure. Yeah, your connection to AWS is just disconnected, but we still have you on screen though.
So why don't you give me 1 minute to restore the connection? Should be back. Yeah, so sorry, and should be back now. Okay, so I deploy a new application and call it Bitnami Kubernetes sandbox. Okay, so can you hear me, right? Okay.
We can hear you, Tuan. Yeah.
Yeah, so now you deploy a new one. Okay, sorry about that. Okay, that should be very quick now.
Yeah, generally, it doesn't take very long.
No, it's called the COVID, right? You know, you have a slow connection. So one click and you deploy it in a few minutes, and maybe less than that, and I choose the key, and that's it. And you run Kubernetes ready to go. You don't have to do anything else than just one click. And now we get into that. So when you deploy, and I have one cluster deploy in here. So because I do a live demo, so show that the real thing. So we call that the Acme or whatever names, Bitnami. Is it an application, Acme, Bitnami? So I have it here, and I'm gonna log into this cluster. So it's running right now. It's initialized in just 2 seconds. Hopefully, very quick.
Yeah, so this is a fully compliant Kubernetes
So
cluster with etcd, master, and worker nodes.
Brand new clusters and coming in a few seconds. Let's refresh it. And then when it's done, we're gonna have the windows. We're gonna log into that. So I have it here. So what is Bitnami? What to call it? Bitnami. I call it.
You called it Acme Bitnami.
Yeah, but it's not coming. So
still initializing.
Just loading. This is from scratch, so it's loading. So when it's loading, I'm logged into that, and we're ready to go. Yeah, and everything play for me. Yeah.
Yeah, so once it's loaded and created, you could easily run your Kubernetes commands like kube control get pods, and then you can see all your pods running on AWS.
Yeah. So I have the policy been deployed. This is the IP address. I just grab it. I log into that, and I just wait until it's coming to make sure that it should be normally very quick. So if not, I switch to the one I just created right before 3 minutes ago. This one. Okay. So we can onboard this one and wait for this one coming, and we onboard this one, the second one. Let's do the one I just created. So onboard this one later. So let's log into this one. Okay. Call it Bitnami tree. And when it's coming, we have two. Then okay. And one call it Acme and one called Bitnami tree. So let me log into the old one. Hopefully it's coming shortly. It's load the EC2X large, but that's why an SPU. So and then let's see Bitnami, and then put my credential into that, and then logging. So this is my brand new cluster just deployed a few minutes ago. So we have kubectl get hot. There's nothing in that. So there's nothing in that. So that's a brand new, not fact, right? So now we go and deploy some applications. So let's deploy one application. Try deploy Nginx, see how it looks, and then we go onboarding this cluster into okay. So anyway, you don't have to do this. kubectl hot. It's coming. Oh, that's coming. Why don't we switch to the new one? You want to switch to the new one?
Yeah, so now we see the Acme Bitnami is running on AWS. So let's go for it.
Let's go for that. Yeah,
from Acme.
So as I said, do that and SPU, put the key into that and put Bitnami user, and then we're ready to go. And then yes, and then CTL get pod on namespace. Right now we have no namespace yet, so we have not yet onboarded. So we're gonna onboard it to. So yeah, you need to run the sudo su, and then you give the permission. Where I have a permission in here, so give their permission in here, and we're ready to go. That's the permission. That's the Kubernetes, it's not us. So run the command, and then ready to go. Pod. Let me see what I'm missing here. Oh, I'm missing here. Yeah. Different new setup. Okay. Okay, now good. So now I'm gonna go and run Tanzu mission control. Okay, let's onboard it. Okay, so this cluster gonna be here. We onboard a new cluster. Basically, when the way you onboard it, you just attach the cluster. You click on here. You choose this is Tanzu mission control. You already logging. You choose the full namespace, or you create your own namespace. You call it demo file and SVU. And then you put a key description, or you register. Basically, you run this command, and every single part you have, and every cluster you have. So I run in new cluster I have. So I run this command. Basically, you go and create a namespace called a VMware TMC namespace, and from there you're gonna connect to Tanzu. So just one single command, and now you're ready to go. And you go to here and you verify the connections, and everything connected. You should see the workspace you just create in a cluster in here. So I have it here. So see that two coming. So number 4 just coming. So when you log in here, you can see just waiting 1 or 2 minutes, it's coming. And then you see the one you just created earlier. So they have all the cluster information. Let me make it full screen. You see everything here. So that's a node, the controllers, everything very nicely presented. There's a version of your Kubernetes, how many nodes running, in the namespace. We create one application, so that can go here. That's the Tanzu mission control. They're gonna run to this namespace. They're all services running by Tanzu in your cluster. And from there, it takes you to all the information, right? And then on top of that, you can create a workspace which allow you to group multiple namespace together. So this is the new workspace. It's a logical construct like Susan just mentioned. This is the global namespace in networking. This is for the compute and storage. You can create a workspace and create a new workspace and workspace one, and then you group multiple cluster together, namespace together. So that you can do it. You have to remember stuff better. So yeah, let me try. What's wrong with that?
Yeah. So the workspace concept is a logical concept, and now you can group namespaces.
Yeah, I can group multiple namespace together, and then I can bring some action. We add them together and edit the labels, and you bring some workload together. So right now we have some more workload coming. We're gonna go back and add the namespace into that. So there are a couple of namespace that have been created already. You can group them together, attach them. There are multiple ways you can do in the interest of time. We're not gonna go too much in detail on that. We can switch gear to the networking space where you're gonna how do you connect that to the networking space and the issue service mesh that Suzanne just mentioned earlier. So I'm gonna show the high level here, and I switch gear. Now it's been attached, right? And then what we're gonna do is we switch gear to networking. So in networking, basically we have the Tanzu service mesh, where Susan just mentioned, right? So we're gonna install, now it's working. Now you install the Tanzu service mesh after you onboard it. So there are commands you run in your cluster here, and then from there you take you to the Tanzu service mesh. When you run it, I only ran it. I would not go again and run again. But basically, when you run it, your cluster should show up in here, basically. So let's install service mesh. And during the time, I had another cluster showing already. So that's installing right now. Okay. So when installing, we have that thing is deployed. That's a new cluster. You see that just coming, Suzanne. And now when you have it installed, that create multiple clusters. We have in this Kubernetes deployed it by Vietnamese. So we have some here in ACME North and ACME South, and we have Istio in this way deployed along with the catalog service. And between them, they have the showing all the traffic coming between them and all the latency and performance things like that. You can, how many services been deployed on catalog services, and all the things have been deployed in here, and how many service instances. The cool thing about that is you can see all the detail about your cluster here, right? You can see the system, the heat maps, all kind of things, and the performance key matrix, everything is live demo in here, right? Then you can see infrastructure, you see multiple ton of use cases we developed on top of that. So cool thing about that is the GNS, the global namespace. You want to talk a little bit more about that, Susan?
Yeah, so we explained earlier that the global namespace is a logical concept that you can define it for an application and it becomes a tenancy model for, say, the application team or the business team. But then it actually removes the limitation of the single Kubernetes cluster. So Tuan will be showing this Acme application a stretch across more than one Kubernetes cluster. And so when we talk about all those services that it makes up the application, Tuan also demonstrated you can examine the amount of time it takes to traverse between the services. So imagine you can define an SLA for entire application traversing through all the services. And if it didn't meet that response time, the system is smart enough to remediate the resources so that it will make the define time that has been specified by the operator.
So the one we created, the default, and the new one onboarded, the Acme itself, and both them together, we group them as a logical construct. In Kubernetes, only have the concept of namespace. The GNS is sitting on top of that to plumbing all the networking between the two namespace or multiple namespace. Here we see that here we can put some conditions, and we group all the services together as a single box, and we apply the single policy across multiple Kubernetes clusters, where we are in a unique position can do that. It's a VMware solution, part of the Tanzu offering. So when you click here, you can do encryption across multiple namespace. Here, there's an MTLS being encrypted. And then from there, you click next, and you will reveal the whole configuration you've been doing, and you hit finish. And the whole policy, we just go to from step 1 to 5, it can be applied across multiple namespace. I would not do again, but that already been done. So that's exactly what we've been showing here in the demo. Yeah, we can go more and then to that. This is a name global namespace. You see some GUI and some detail about that as well. Yeah. You want to show something, Suzanne? I think that's the heat map. I want to see that exactly.
Yeah, this is great.
That's a real-time traffic coming from outside to our Acme Finet we just deployed earlier. Yeah.
So you can examine the CPU usage of the different services. So example, some of the Redis service might take more CPU or more memory intensive. And then you can also examine the latency so that by looking at the entire transaction, maybe it's certain parts of the application may take more time. And so you can optimize certain parts of the application. But without this type of information, you can't tell where your bottlenecks are. But just from looking at this now, you could see that maybe from the front end to some of the services like from the front end from the user to maybe some of the database services seem to take a little bit longer. So you can optimize your services.
Yeah. You can do more granular with our RB load balancers instead of the default ingress. That right now this is default ingress. It's easy to replace that and give more visibility, either north, south, or east, west traffic. And traffic coming here to go to the front end and go to load balancing between different things services. You can put a second load balancer to visualize all the traffic coming here. You see this the first level is great. Even more detailed RV and all the type of services we're offering, we can see even more detailed granular onto that. So when you click on here, one of the services, you see all the dependencies. When the checkout services, go to cart, go to Redis, and how much time it take. In this case, the front end take less time than the back end, where you read all the thing to the memory like Redis here. Right? So that you can go very granular in every service, how much CPU, RAM, resources been consumed on each service. Yeah.
So
Very powerful concept.
we talked about deploying the applications across multiple cloud, hybrid cloud as a use case. We actually didn't talk too much about traffic routing. So in software development, there might be times that you're testing a new release of a software, and you
Mm,
might want to direct a partial part of the traffic to the new application. Not all of
yeah,
it, maybe just a percentage of the traffic,
yeah,
so that you
yeah,
could test that application. So you
correct.
can do that with the software with Tanzu Service Mesh as well. So
Yeah,
this is helpful in
yeah,
the software testing,
correct.
blue green deployments.
Yeah, the thing is, we have ton of ton. Here only 4 cluster running 4 different type of clouds, and connect them together in single pane of glass. We can do a lot of things, automation, pushing policies across multiple cluster on in single clicks. And also, and we have the yellow part on the CNI plugin provided by VMware and our partners. You can enforce all the policies to the layer 2 and layer 3 and connecting to NSX if you have it on-prem running or other type of services running in the cloud. You can have the full enforcement from the layer 2, layer 3 is the yellow part, and the blue part can do all the way to layer 7. Very powerful concept, and then across multiple clouds. And we in the unique position can deliver this kind of message to the market, and kind of consistently across the board, multiple clouds is challenging for customer. With the Tanzu Service Mesh is a very powerful concept you can apply for.
Yeah, so it really is the power of that whole portfolio. So you saw Tuan use the Bitnami, which is now called the App Catalog. You see, Tanzu Mission Control that allows you to manage multiple Kubernetes clusters. You onboard them, and now in addition, you see Tanzu Service Mesh that helps you with policy and connecting and securing the microservices that are part of the cloud native applications. So we think that the whole portfolio is very powerful in addition to the networking and security functionalities that's from the NSX portfolio. So you also saw NSX Advanced Load Balancer, and you also saw the capability of using a container plugin from either NSX container plugin or even a Project Entrea, which is the open source in cluster native container plugin. So putting it all together makes it very very seamless, and it's easy to manage from a single dashboard with just a few simple clicks. So that is the conclusion of our demo. If you have any questions, please feel free to put them into the Q&A session, and we can stay on a few minutes to see if there are any questions. If there are no questions, thank you very much for listening. We do this all day long. We really love telling people about Kubernetes, about service mesh, about networking. And you can find us on VMware at NSX on Twitter, or you can find us on social media. Feel free to reach out. Thank you very much for listening.